Welcome back, everybody. In today's video, we're going to be looking at the related function, which is a very powerful function, but almost more importantly, it's going to be a great way to explore the idea of expanded tables, which are useful for working with related, but are useful for several other things. So without further ado, let's pop over and we'll sketch this thing out, shall we? Okay, so I am here without a whole lot of stuff, right? So let's add some stuff. We're going to start, as we often do, with the data model. So in order to show this idea of table expansion and the related function, we're going to need a model that has not just one relationship, but a couple relationships, because to make the idea a little bit easier to see. So what we have here in our data models, we've got three tables: a sale table, a prod table, and a cat table. These are corresponding to the sales transactions table. This is all the sales transactions. For each sales transaction, we have how many things were bought, the quantity, the product ID, which is not a normal product ID that you would see, it's just the actual name of the product, but that's fine. Coffee, tea, scone, or bagel. And from the sale table, we have a many-to-one relationship with the prod table, which has all of our product information. So for each product ID, coffee, tea, scone, or bagel, we've got the price and the category ID, cat ID, right? Which allows us, through this many-to-one relationship to the cat table, or product categories table, connect us to the different bits of category information, including, and well, not including, basically just what is the cup fee. And by cup fee, we're going to imagine that our fictional coffee shop thing, right, exists in a place where the city or whoever requires that they charge 25 cents per cup, just because there's so many cups lying around. You have to pay somebody to go pick up all these cups off the street. That's sort of the idea there. So if somebody orders something that involves cups, like coffee or tea, they got to pay 25 cents per cup. And if they order some food, there's no cup fee at all, because there's no cups. Okay, so that's our model. Keep in mind we have two relationships. From the sale table, we have a many-to-one relationship to products, which has a many-to-one relationship to the cat table, or category table. Okay, so there's our data model. What else do we have? We have this measure called sales including cup fee, right? So what this should be is the total sales including the cup fee, which is why I named it that. So the way we get total sales is for each one of these transactions, we're going to multiply the quantity, like if we just look at this first row here, we're going to multiply the quantity of 2 times the price. Now notice that the price is not in this table. It's over here in the prod table, products table. But we can say, well, if it's coffee, we know that coffee corresponds to this row, so we know the price is $2.50. So we multiply the quantity times the price, but we have to remember to add the cup fee. Keep in mind the name of the measure is sales including cup fee, right? And so in addition to multiplying 2 times $2.50 to get the sort of regular sale, we have to include the cup fee, and since we know, there we go, since we know that this is a beverage category, right, we know that the cup fee is 25 cents per cup, okay? So that's sort of the business logic there. Now, you'll note, right, if you're looking at this, there's a slicer where we set, or the user sets, the quantity equal to 4. So this is a little weird, right? This filter on quantity equals 4, it's not a common filter that you would see out in the real world a lot. It's on this column right here, a column of what we would call the fact table. It's weird that a user would say, show me these sales, but just the ones for when somebody ordered exactly 4 things. You could do it. It totally works. This totally works from Power BI. I'm doing it here because it's going to help illustrate how this notion of expanded tables works. So you might think to yourself, well, normally I'd have a filter on the product ID or the category ID, or I don't even know, maybe the cup fee. I don't know why I'd have one here on quantity. Just go with me. Just go with me. It's going to help out, okay? And this does work, like I said. Okay, so we've got our data model, we've got our Power BI visual, where we've got this sales including cup fee measure, and the user is sliced down to all the transactions where the quantity equals 4, which, by the way, if we're looking at our table over here, corresponds to just 2 transactions. This transaction over here, where they bought 4 teas, and this one here, where they bought 4 scones. Okay, enough of that. So what else we have? Well, it'd be useful to know what the definition of this measure is, sales including cup fee, right? So this is going to be this sum x over the auto snapshot of the sale table. We'll get into what that means in a second. And all this stuff over here, and importantly, we have the related function showing up twice. For folks familiar with sum x and iterators in general, argument 2 of sum x is the per row formula. This is the formula that's going to run once per row of whatever table we gave it right here. This related function is going to allow us to do some interesting stuff with what the concept of the current row is. But again, that's a preview for later on. Okay, so here's the measure. This is what's going to run. So why don't we start by sketching out the initial filter frame, right? So if we think about running the measure, sale including cup fee, right here, well, this visual, right, is affected by this slicer right here. So if we think about the initial filter that we're going to run the measuring to get this 22 bucks, well, we could draw that out here with this little frame. So this is the initial filter frame for the measure. And what is the initial filter context? Well, the user has selected quantity equals 4. So the initial filter context, we could draw it out like this. The initial filter context has one temp table in it. That one temp table is one row by one column. It's on the sale quantity column, right? Sale quantity. And it's for the value of 4. So we're only looking at transactions where people bought exactly 4 things, which again is a little weird, but will become useful later on. By the way, every filter in the filter context is a temp table. So in addition to sort of whiteboard sketching it out like this, I can also render what the table looks like over here, right? So when I draw out this right here, you can imagine this temp table in your head, right? So up here we have the model tables, what we've loaded from Excel or SQL or whatever. But when we're evaluating our formula, everything happens with temp tables, including this filter, which is a temp table that looks like this, right? It's a filter in the form of a table, form of a temp table, for the value of 4 on the sale quantity column. Okay, so now that we've got that set up, let's think about, well, actually, before we dive too deep into execution, let's remind ourselves that what we're going to do is we're going to run this whole bit of code here, this measure definition, this measure formula, inside this frame, right? And let's think about what we're doing here, right? We're just going to kind of think in tables for a minute. What are we trying to achieve? Don't worry, without thinking too much about the code, what do we need to do just to get a number that's meaningful here, right? Well, what we want to do is we're going to start by getting some sort of temp table of all the visible transactions, right? Because we need to get all the transactions because we're trying to figure out what sales is. Now, in addition to just the information in this table, we're also going to need the price and the cut fee, which is stuff from different tables. So our temp table is going to have to look something like this. It's going to have all the stuff in the sales table, but it's also going to need to have this stuff from the products table and the category table as well. So we'll need somehow to get a temp table that looks like this, right? And then once we've got it, what we'll have to do is we'll have to get each row's sale amount. And to get each row's sale amount, for each row, we're going to multiply here's what we're going to do. We're going to take the cup fee and add it to the price, and then we're going to multiply that whole number times the quantity, right? So if for every beverage that we sell, or for every cup of tea that we sell, we got to charge $2 for the base price, plus 25 cents per cup. Well, that's $2.25 per cup, times 4, that'll give us the number for the top transaction, and we'll do the exact same thing for the bottom transaction. We add the cup fee to the price to get sort of the extended price, right? So 325 plus 0 is 325. We multiply that by 4, and that'll give us the number for the second transaction. Then once we have both of those numbers for each row or each transaction, all we got to do is add them together, right? So table-wise, that's all we're doing. The hardest part is getting this big, wide table that has the information from not 1, but 1, 2, 3 model tables. Once we have a temp table that looks like this, it's a simple process of iterating over each row and getting each row sales and summing things up. That's what we're going to do. So let's go see how we actually do that. Okay, so the first thing we're going to do is we're going to, in our measure, execute the auto snapshot by typing in the name of the model table that we want to go get a temp table based off of, right? So when we type in sale here, what we're saying is, go take the auto snapshot of the sale table. Go get me all the visible rows of the sale table, right? Not all the rows, mind you. We've got this filter for quantity equals 4, so just give me the ones where the quantity equals 4 is, which should be that row and that row right there. So when we do that, what we end up producing is a temp table that we could sketch out like this, that has all the visible rows of the sale table. It's not a single column, but all the columns of the sale table, right? So I've got that star in there. And this is 2 rows by 2 columns plus. Now what's with that plus, right? I bet you can see that if we're looking at just rows where the quantity equals 4, well, it should be like that right there, which should be like a 2 by 2 temp table. And it does say 2 rows by 2 columns, but there's a little plus. The plus is basically what we're going to be dealing with this in this video. When we take this auto snapshot, in addition to the base columns, we're going to get a couple extra columns, right? couple extra columns coming along the right. Let's go see what that looks like. Okay, so if we think about doing this auto snapshot of the sale table, what you're probably imagining in your head, what most people would imagine, is that the temp table that you get looks something like this, right? With those two rows right there, T and 4, scone and 4. T4, scone 4, right? Now, you'll notice on the edge of my temp table here, as I've rendered, there's this kind of funny little edge to it. It doesn't look like the other edges. That's because in addition to these sort of normal columns that we're going to get, we're actually going to get a couple extra columns. Let me show you how this works, okay? So we're going to start here. Let's kind of come up here and see. We're looking at those two rows right there, the T row and the scone row, right? So if we think about it, if we know that we've got these two rows right here, and we also know that we've got this relationship between the sale table and the products table, and it's a many-to-one relationship. So if we're starting on sales, the product is on the one side of that relationship, right? We essentially have a lookup direction, right? So this relationship, if you're on a particular side of it, you can look up to the other side. So if we're down here where we've got T and scone, we can look up to the products table and get information from this table. So again, if I know I've got T and scone as my transactions, because I've got this relationship, I know that this transaction is related to this row in the products table for tea, $2, and beverage. And I know that this row right here, where we've got scone and 4, well, that's related to this row in the products table where we've got scone, $3.25, and food. So in addition to these two sort of normal base columns, I've also got, in my temp table, these three columns right here. One for product ID, one for price, and one for category ID. But that's not all. That's not all, right? Before we had this many-to-one relationship that allowed us to go from this table over to this table right here to go from sale to prod. But if you look, we've also got this relationship right here between the products table and the category table. And once again, we're going from the many side to the one side. We're starting over here with category ID, and we're heading over to the left based on this relationship. We can use this category ID to go look up what the row information is in the category table, right? So because of that, in addition to knowing all this other stuff, we also know that this bev looks up here to this row where we know that the category ID is still bev, but more importantly, we know that the cup fee is 25 cents for this first transaction, right? We've started here, we've looked up here, and we've also looked up here using these relationships. And in addition, for this second row right here, because we know that this is the category ID of food, we could use that to look up this row right here. We know the cup fee is exactly $0.00. So in addition to being able to look up these columns over here, we can also look up these columns right here, right? The cup fee and the category ID. So your initial inclination that you get these two columns is correct, but when you're doing the auto snapshot and you've got relationships involved, and specifically where you're starting, there is a chain of many-to-one relationships, or kind of lookup relationships, if you want to think of it that way. You actually, in addition to getting the values of the table that you actually point to, the sale table, you also get any kind of lookup tables. In this case, all the columns from the product table and all the columns from the category table, prod and cat. Okay, which brings us to our first sort of definition, talking about expanded tables. So when you are snapshotting a whole model table, right, which is to say your snapshot involves typing in the name of the whole table, not just a column, right? So here we've got the auto snapshot. It's a good example of this. We could have also done all sale or all selected sale. We would have the same behavior, right? But here we're doing the auto snapshot for sale. Whenever you're doing that, what you end up with is a temp table with two types of columns. What we might call the native columns, which are all the columns of the model table that you pointed to, which is to say all the columns of sale, like right there and there, respecting the filters, right? You also end up with the related columns, which are also sometimes referred to as the expansion columns. And these are all the columns that can be looked up across the relationships, the chain of relationships, okay? So a couple notes here, right? A column can be looked up if it exists, or they exist, over any number of many-to-one relationships when starting from the original snapshotted table. That's sort of a mouthful. All it means is if we're starting here, as long as the table that we're looking up is on the one side of the relationship, we can get all those values. Since this one's on the one side of the relationship, we can get all those values. If we started here on this table, we'd be able to look up this direction, but we wouldn't be able to look up this direction. So our snapshot would have these extra columns, but not these. You're always looking up from the many side to the one side. Many side to the one side. So in addition, if you kind of like my animation showed right here, you can sort of think of this as the temp table expanding like a balloon until it has added, or maybe even collected, if you like that verb, all the columns that it can access across relationships. The final version of this is often called the expanded table, or the expanded version of the table. So the term table expansion refers to getting that initial set of rows and then using the relationships to kind of do one or more, or often several lookups to go scoop up all the columns that you can get based off of those chains of relationships. Okay. Now, these related columns are used internally mainly for applying filters from the filter context. We'll get into that in a future video. The reason these things really need to exist is these are how filters get applied in the DAX language. But in addition to that, there's some other stuff we could do with them, and one of the things we could do with them is use them with the related function within iterators, which is what we're about to get to next. Okay, but let's stop right here and pause. Right. So whenever we take the auto snapshot or any snapshot where we're pointing to the entire table, in addition to all the native columns, we get all of these additional related columns that can be grabbed via using these relationships. And when I draw these, I kind of draw this little line right there because these columns are sort of hidden. We'll get into that in a second, right? These are columns that are definitely added to the table, but you sort of have to know they exist. They're sort of almost like ordering off the secret menu or something like that. Okay, so we've got this notion of expanded table. Let's go do something interesting with it, right? And the thing we're going to do with it up here is we're going to pass it into the SumX iterator. Now, SumX, if you've seen my videos before, it's an iterator, and like all iterators, it will take the temp table, right, the temp table that I've got rendered out right here, and create a set of row contexts, and then run a per row formula in it. So let's talk about the row context that it generates. Okay, so we take this temp table, pass it into SumX. What does it do? It generates a set of row contexts, and the row context it's going to generate look like this. There's the first one. There's the second one, right? Notice here, for this row context right here, this is for the T row, which is the top row. SumX takes this row right here and creates a row context, which is sort of a set of named values, key value pairs, if you like that term, wherein which we will be able to execute a per row formula that can access any value of the current row, sometimes called a current row value. What's meaningful here is, in addition to the regular items in the row context, right, quantity equals 4 and product ID equals T, we also have these related values where the product ID equals T, the price equals $2, the category ID is beverage, and the cup fee is 25 cents. So that is meaningful because we are going to be able to use the related function, to jump ahead a little bit here, we're going to be able to use the related function in our per row formula to access these sort of secret current row values, Down here, we've got the row context for the second row. In addition to sort of our normal current row values, quantity equals 4 and product ID equals scone, those values of the current row, the row context also has these additional values of the current row based off of the related columns, right? Which I think takes us to our next principle. Oh, no, we're not the principle yet. Okay. So what are we going to do with these two row contexts that SumX has created? Well, we're going to execute a per row formula. Let me kind of back up here a little bit, right? So just hit rewind there. So SumX has taken this temp table that we've created and generated a set of row contexts. So what are we going to do with it? Well, here, for argument 2 of SumX, we're going to enter our per row formula. There it is, okay? This is the per row formula, which, as the name suggests, is the formula that we're going to run once per row, right? So since we've got 2 row contexts, or 2 rows, we're going to run this formula here, and we're going to run it there. So just like that. So whatever we type in here is going to get run in each and every row. We've got 2 rows in this case, so it's going to get run twice. If we had 200 row contexts, the per row formula would run 200 times. If we had 2 million row contexts, the per row formula would run 2 million times. However many rows we have in our temp table, the iterator will create that many row contexts and will run the per row formula in each and every one of them. Getting a slightly different answer in each one because the formula in the per row formula is pointing at different objects in the current row context. Or maybe more accurate, it's pointing at the same named things, but you're getting different values. So up here, the product ID is T, and down here, the product ID is scone. Okay. So speaking of which, let's kind of poke at that a little bit. Now, this per row formula is kind of complicated, especially if you're looking at it the first time. Look at all this stuff in here. So here's sort of the simplified version of the business logic version. For each and every row, we're going to take the regular price, add the cup fee, and multiply that whole number times the quantity. That's what all this stuff is up here, right? So this whole thing here is the price. This whole thing here is the cup fee. We add those two together. We get the price plus the cup fee. And we multiply that by the quantity. That'll give us the sales for each row, including that cup fee, okay? So what I want to do now is I want to think about not both these rows, but just evaluating the per row formula in this top row context up here, just right up here. We'll come back to this one in a second. Let's just think about this one right here. So if we run this per row formula, right, in this row context, what are we going to get? Well, let's think about this, right? If we look at the per row formula, there are several references to value in the current row context. And by several, I mean 3. There's a reference to the sale quantity, which equals 4, a reference to the product price, which equals $2, and a reference to the category cup fee, which is 25 cents, right? Let's go through each one of these guys, okay? So in our per row formula, the first reference is right there. This is going to evaluate to 4 in just a second, right? That's the first one. That's the easy one. This is like sort of regular old iterator stuff. Here, let's go look at the second one. It's more interesting. In the second one, we want to go get the current row, the row context value for the price. Now, we see here that the name of the column is product price, right? Price in the product table-ish. That's sort of the full name of it, right? First and last name if you want to think of it that way. If you look at our per row formula, though, it doesn't just say prod price. It says related prod price. The reason being that if you want to get any of the values sort of to the left of this little special line right there, right? All of the values from the related columns, you can't just type in the name of the column. You have to use this related function. What it lets you do is it tells DAX, hey, when you go look in the row context, don't just consider the normal values. I want you to go look at the related ones as well. So go look at all the different related values and see if there's one called product price. And if there is, bring that back. And DAX will say, yeah, there is one in the related area called product price, and it's $2. And so this is going to be $2 down there in just a second, right? Likewise, this next reference right here, related cat cup fee, right? The related function says go look in the row context, but don't just look in the regular values. Go look within the related values, and within those related values, see if there's a value called cat cup fee. And sure enough, in this row context, there's a value called cat cup fee, and it is 25 cents. So this bit right here will resolve to 25 cents. So let's actually see the next step, okay? There we go. Okay, after all that talking, this per row formula run in this row context generates these numbers. We're not done yet, but we've taken the references and actually converted them to numbers that we could do some simple math with. So all this stuff right here, sale quantity, that gets the 4 right there. Related product price, right, related product price gets the $2 right there. And related cat cup fee gets the cat cup fee in the related section, which is 25 cents. So now we just got real simple math. 4 times 2 plus 25 cents. Well, let's just add the 2 and 25 cents. Oh, shoot. I'm getting ahead of myself here, right? We've got my principal. We'll add those together in a second, right? Okay, so let's talk about related columns and how they interact with row context. So when iterators create a row context, any related columns of the source row are added to the row context, but they are hidden, right? To use the values in your per row formula, the standard column reference must be wrapped around the related function. And that's it. That's all you got to do, right? So if you've got a row, right, where you've got a bunch of related values from that table expansion we saw a second ago, in your iterator, you could grab any single one of these by typing in the name of the column, but you can't just type in the name of the column. You have to type it in and then wrap it in the related function to know that you should go look not in the normal columns, but back here with all the related columns. Now, I often think of these extra values as being like in the back room, right? Or ordering off with a secret menu. So when you go to a grocery store, you know, they don't see anything out front. You say, hey, by the way, you got one of these in the back? And the clerk goes in the back and says, actually, yeah, we do. Or you're clever enough that you know that, yeah, it's a hamburger place, but if you know the right person to ask, you can get, I don't know, a salad or something like that. It's not on the menu, but if you know how to ask, you can get it. So I think of the clerk as kind of standing in here. When you use the related function, they go through this secret back passageway and go look at all these extra values of the current row that are not normally available to folks, right? Now, that brings up the question, why do they do this, right? Why do they make you use this related function? I think the real answer, I don't know this for sure, but my best guess is this related function is just meant to make it a little bit easier for human beings to read. It has less to do with the way that the program deals with these column names. It has more to do with making it a little bit more obvious that when you say prod price here in your per row formula, you mean the related value of prod price, right? You mean the one that you got using the relationships between the sale table and the product tables. That's sort of why they do it. Okay, so after all that, let's go do some math. I hate, whenever I've got math on the screen, I kind of want to do it. It's just sort of a personality. I don't know if it's a personality flaw, but it's a personality thing. So we've got 4. We got 4 times 2 plus 25. Let's add these guys together first. So we're essentially saying 4 times 225. And 4 times 225, well, what is that? That is $9. 9 bones. And that $9 is the answer, the result of running the per row formula in this row context. I'm going to go ahead and just underline it right there. But we're not done. We have to run this per row formula again down here. So let's go ahead and focus on that. So here we have the exact same per row formula. No changes at all. But this time, when we run that exact same per row formula, the row context has the same names of values in it, but the actual values attached to them are a little bit different, because this is a scone row, not a T row. So let's see that, right? So we're going to go ahead and run this. Just like before, sale quantity still refers to the number 4, but that's where the similarities end. So now, our second reference here, we say related prod price. Go look in the related section and see in the related section if there is a value with the name prod price. Sure enough, there is. Now, last time it was $2. This time, or $2 right there to be even more specific, this time it is $3.25. So this time, this will return $3.25 down there. And likewise, if we look at this reference, related cat cup fee, related says go in the row context and look in the related section. Don't look in the normal section, it ain't out there. Go look in the related section and see if you can't find something called cat cup fee. And sure enough, in the related section is cat cup fee, and it has the number of $0.00, okay? So this will return $0.00. Let's go see what that looks like. There we go. So we've got 4 times 325 plus 0, okay? Now, if you're pretty good at math, you might know that 325 plus 0 is indeed 325. So essentially what we're saying is 4 times $3.25. So you get a calculator out, and that turns out to be 13 bucks. 13 bucks. And that is the answer when we run the exact same per row formula, argument 2 is sum x. This time we're running in the second row context. We don't get 9, we get 13, because the row context has a bunch of different values and a bunch of different numbers. Okay, so we get 13 right there. Okay, so now we've got the answer for this row context and for this row context. Since we've only got 2 row contexts, that's all the answers. If we had 2 million row contexts, we'd have a whole bunch more work to do, and it would take me a very long time to get through it. Luckily, we've just got the 2. Okay, so now that we've got our answers for both cards, 9 and 13, what is the sumx function going to do with it? Well, the name of the thing is sumx, which is a pretty good hint. Sumx is going to take the result of running this per row formula, in this row, and all the rows, basically, and just add them together, sum them all up. So sum x, we'll say I'm going to take the results, 9 and 13, and add them together. So 9 plus 13, what does that equal to? Well, that equals to $22. And that is our final answer. That is the sales, including the cup fee. And that is how we were able to run this whole big, long measure and use this related function to, within each per row formula, reach into the related section of the row context and get all those values that were the result of the table expansion, of the continual joining outward, starting on the many side and going to the one side, or one side, or one side, to go scoop up all these extra columns, and then we can use them inside the iterator, right? Okay, so there's a whole bunch more we can talk about in terms of related columns, but I think that's a good first step. So with that, thanks so much for your time. I hope you enjoyed it, and I will see you in the next video.